let's use the idea that we can use the average as the center of a data set, and we can talk about how spread out the data set is by using the standard deviation to give a relationship between every point and the center. So here's a data set X, which you can compute, or you can trust me, the average of that set is equal to 3, and the standard deviation is equal to 2.16. So here's our average of 3. And we are going to compute the z-score of every point. So reminder, the z-score of a point X is equal to the difference X minus mu divided by the standard deviation. So it's the distance X is away from the center. And then that division by the standard deviation tells us the number of standard deviations that fit inside that distance. So it is exactly the number of standard deviations away from the center. So let's compute the z-score of the first point, 3. So the z-score of 3 is going to be 3 minus the center over the standard deviation. Well, 3 is the center. So we get a z-score of 0, right? 3 isn't to the right or to the left of the center. It is the center. Now let's compute the z-score of the second point, 1. The z-score for 1 will be 1 minus 3, because that's the average, divided by the standard deviation, 2.16. So if you compute this, you get minus 2 divided by 2.16. That gives you about minus 0.93. So that tells me that 2, sitting right here, is 0.93 standard deviations to the left, right? That's what that negative right there means. Now let's compute the z-score for the next point, 5. The z-score for 5 will be 5 minus the center divided by the standard deviation. That gives us 2 divided by 2.16. That gives us a positive 0.93. So a 5 is positive 0.93 standard deviations away from 3. So notice 5 and 1 had the same magnitude of the z-score because they were the same distance away from 3. They were just on opposite sides. So the 1 got a negative 0.93 and the 5 is a positive 0.93. Let's keep going. Z-score of 2. 2 minus 3 divided by 2.16 gives us minus 0.46. So 1 was right there, and it was 0.93 standard deviations away. 2 isn't that far away. It's just 0.46 standard deviations away. In fact, let's use that to make the next calculation easier. If you know that 2 is 0.46 standard deviations to the left, then the z-score of 4 is going to be 0.46 standard deviations to the right, because 2 is 1 unit away from 3, and so is 4. Let's show that. 4 minus 3 divided by 2.16 gives you 1 over 2.16. That gives you 0.46. Okay. Last 2 points. 6 and 0. The z-score of 6 is 6 minus the average 3 divided by the standard deviation, 2.16. That gives us a z-score of 1.39. So 6 is all the way over here. It is more than 1 standard deviation away. It is 1.39 standard deviations away. And finally, z-score of 0. By symmetry, we know we're going to get the same as the z-score of 6. Minus 1.39. Bad handwriting there at the end. Minus 1.39. All right, and notice all of these z-scores are unitless because as soon as we construct this ratio right here, x minus mu divided by standard deviation, because x and mu and standard deviation all have the same units of measurement, that's a ratio, it doesn't have any units.